In this video, we're going to explore solving systems of equations using the method of elimination. This method is important for us in Math 10 because it's the last of the three strategies that we discuss, and especially because it's a friendlier strategy for many Math 10 students when the numbers match, and because in many cases you'll be able to choose which strategy to use. So if you find this a friendlier strategy, you want to make sure that you get really good at it. Like substitution, solving with elimination is based on the use of algebra, so we consider it an algebraic solution. Solving by substitution is based on adding or subtracting entire equations together to eliminate, sometimes we say to cancel out, one whole group of variables. We've been doing something like this the entire time we've been solving equations. Consider this equation. If we want to move that positive 5 over, we want to eliminate it from that side of the equation. We eliminate that positive 5 by subtracting 5. The positive 5 and subtracting 5, or we can think of it as positive 5 and negative 5, eliminate each other. They cancel out. The same kind of thing would happen if we add the two equations on this side of our screen together. The positive b and the negative b are going to add up to 0. A plus A will leave us with two A's. Positive B and negative B eliminate. If we want to, we can think of this as 0 B's, although generally we don't write that piece down. 8 adding 2 will be 10. So if we know that 2A is equal to 10, we can keep solving to find out that A is equal to 5. And this is the basis of the method of elimination. When you are solving using elimination, your first step is to decide which variable group is going to be easiest to eliminate. You might need to rearrange or multiply the other equations so that we can help eliminate your target. When you're ready, you combine your equations. You can think of this either as adding the two equations together, or you can think of this as subtracting the equations. And when you're ready, solve for the remaining variable. Just like substitution, you'll use the answer you find to help find the value of the other variable. Let's take a look at some examples. In this first system of equations, we notice that we have negative 4y's and positive 4y's. Adding these two equations together is going to cause us to have 0 y's. Let's see what happens. When we add 3x's and 5x's, we end up with 8x's. Those negative 4y's and positive 4y's add up to 0 y's, and we don't need to bother to write that part down. Negative 12 and positive 12 add up to 0. So now we know that 8x is equal to 0, and we can quickly solve for x. In this case, x has to be equal to 0. Now we're going to take that answer, pick one of our equations, put that answer in, and find the value of y. In this case, I chose to substitute my value of x into the first equation. So we talk about three groups of x, or three groups of 0. Subtracting 4y is equal to 12. When I simplify, if negative 4y is equal to 12, y must be equal to 3. So we believe that the solution to this system of equations is the coordinate point 0, negative 3. And that means we believe that 0 and negative 3 make both equations true. We should do a check, just to be sure. Our check, when we put these values into the other equation, works out to be true, so we know that we have a good solution. It may turn out that you come across the phrase double elimination while you're practicing or studying. Double elimination is when you use strictly elimination to solve for both variables. It would look sort of like this. With the method of double elimination, my first time through, I added the equations together to find 2 A's, 0 B's, and 8 adding 2 is 10. So ultimately, if 2A was 10, A is 5. The double elimination part refers to how we would use elimination a second time. My second time through, I want to eliminate the A's, so I would look at subtracting. A subtract A leaves me with 0 A's. B subtracting negative B gives us positive 2 B's. And 8 subtracting 2 leaves us with 6. So we can solve to find out that b is 3. Keep in mind, though, this is not a requirement in Math 10. You're more than welcome to use that substituting in to find the value of the second variable. Let's take a look at this example. In this case, we're going to have to do some multiplying or some scaling in order to help us eliminate. If we choose to eliminate x's, it would be really convenient to have negative 6x instead of 2x to eliminate with this positive 6x. If I would like to eliminate y's, it would be really convenient to have negative 6y's to eliminate with positive 6y's. And we can successfully choose either. For this example, I'm going to choose to eliminate the y's. So I'm going to focus on multiplying the top equation to end up with negative 6y's. In order to have negative 6y's, I'm going to have to multiply positive 3y by a negative 2. So we're going to take the entire top equation and multiply by negative 2. 6x multiplied by negative 2 will leave negative 12x. 3y multiplied by negative 2 will leave us with negative 6y. And 24 multiplied by negative 2 will leave us with negative 48. Now we're ready for the elimination piece. And in this case, with our negative 6y's and positive 6y's, we're going to think about adding these equations together. Negative 12x adding 2x will leave us with negative 10x. Negative 6y adding 6y gives us 0 y's, and negative 48 adding 18 leaves us with negative 30. So if negative 10x is equal to negative 30, dividing both sides by negative 10, x must be equal to 3. We're going to take that answer and use it to help find the value of y. Since we don't have to use double elimination, many students might find it faster to substitute this known value for x into our first equation. 6 groups of x adding 3 groups of y is 24, and we solve pretty quickly to find out that y must be equal to 2. So we believe that the coordinate point that makes both equations true is 3 and 2. Lastly, we'll do a check using the other equation. In our last example, we have a situation where we need to do a little bit of rearranging. If we try to eliminate right now, when we put our equations one above each other, we notice that the equals symbols don't match up. That's a problem. We need everything to line up, so our first job will be to rearrange. Some students might rearrange both equations to be in y equals form, but it's just as easy to subtract 2x from each side of the first equation. Comparing this to our second equation, now our y's line up, x's line up, equals line up, and our 1's line up. And we're very close to eliminating. Some students may think about subtracting these equations. If you're someone who tends to have difficulty with subtracting integers, you might find it easiest to think about changing every sign in one of those equations and then adding. No matter how you think about it, ultimately, we're going to be thinking about negative x equal to negative 3, and so positive x is equal to positive 3. Then we can use that answer to help us find the value of y. In pretty short order, we find out that we believe y is equal to 9. Our last step is, as always, to do a check. And we find out that our check works.